Hey all, so in this section we're going to look at average rate of change. I'll start with going through some definitions here. This is going to relate to slope. Average rate of change is essentially finding the slope of a line through 2 points. We'll look at linear functions more in the next chapter, but this is just going to kind of preview that slope concept that hopefully you have seen from a prior course, and again we will see it again in the next section. So slope, you might remember, is rise over run, where it's how the change in y divided by the change in x. And there's that formula y2 minus y1 over x2 minus x1. We'll use that a bunch in the next chapter. Here we're going to do a variation of that, but using function notation again, since this is sort of our intro to function notation chapter. Looking at this, so an average rate of change doesn't care what happens between the 2 points. So like if I looked at this graph down here, if I wanted to find the average rate of change between this point, and that point, you notice it goes up and then it goes down. We wouldn't care about that piece of it. We would just care how did it change between those 2 points. So we're not worried about the path, we're just worried about kind of the outcome of how it changed from here to here. So that's what the average rate of change is versus instantaneous rate of change, where we're figuring out what it is at a particular point, and that's what first quarter calculus is all about. So we're just going to look at average rate of change, and with kind of a special attention to the function notation. So if you remember y2 minus y1 over x2 minus x1, if we did that same equation down here in function notation, what happens is if we put in a into a function, we're going to get out a value f of a, the function evaluated at a. So instead of x1 and y1, this is a and f of a. If I put another value into a function b, when I evaluate that, I'm going to have f of b. So this is like my x2 and my y2. So using this slope formula, y2 minus y1 becomes f of b minus f of a, which is still just the y values evaluated at these points, and then over b minus a, that's like my x2 minus x1. So we're still just finding the change in y and the change in x. We're just being given the directions in a little bit different form. So let's see what that looks like, and we'll look at it with graphs and tables and verbal descriptions, and then actual equations. So we'll look at several different flavors of this, but it's all the same basic thing. So for this first one, it's from a graph, and it is, actually let me scoot this over a little bit and get that opened up. We're asked to find the average rate of change from 3 to 5. So from x equals 3 is right here, to x equals 5 is right there. And so you might look at that and think it's going to be 5 because it's changing by 5 boxes, which is true, but that's ignoring like a couple of kind of key features, which is it's doing that over a course. It's running 2 boxes, so we need to account for the x's. It's also decreasing, so it's in the negative direction. So not the worst way to do this is to just write out these ordered pairs, and I'll use that slope formula up above the y2 minus y1, x2 minus x1 on this one. So when x is 3, the output is 5, and when x is 5, the output is 0. And so remember our x1, y1, x2, y2. So if we go to find our slope, which is our average rate of change, this becomes y2 minus y1, so 0 minus 5 over x2 minus x1, 5 minus 3. So our change in y over our change in x, and that gets me negative 5 halves. We can absolutely get that from the graph, but I just wanted to show what it was going to be analytically before doing this graphically. So if you notice, this is changing. It's going down 5 units, right? So if I was going up, it would be increasing, that would be positive, but it's changing, it's getting smaller, so that's going in the negative direction, so -5. And it's doing that while it's running too. So my rise over my run is -5/2. So again, you don't have to do out the points like this, but I wanted to show that why the signs do what they do and why you can't just go, it changed by 5. It did, but it went in the negative direction and it did it over 2 units of run. So 2 ways of looking at that one. Hopefully that makes sense as to why that has to be negative. Same idea, but now we're finding this from a table which we could write ordered pairs from. So it's very similar to this last problem. So you're supposed to calculate the average rate of change. This is the chart shows overdose deaths in the U.S. from 2010 to 2017, and we're calculating the average rate of change between 2014 and 2017. So again, I think I will just write out those ordered pair. Don't have to, but just kind of for clarity for where these numbers are coming from. So 2014 is associated with that output. 2017 is right there. And so then if we're thinking of this as kind of our classic y2, y1, x2, x1, we got our ordered pairs written out nice and neat so we can see what we got. And we'll just find our change in y minus our change in x, or sorry, y2 minus y1, and then over our change in x. So our change in x will be 2017 minus 2014. And let's see, subtracting, we get 23,182 over 3. So there's a total change of 23,182 deaths over that 3-year period, and then dividing, we would get 7,727, and that would be deaths per year, and it's positive. So unfortunately, that was increasing during this period. From year to year is increasing by an average of 7,727 deaths each year. This next one is from a verbal description. This has a little catch to it, so definitely pay attention here. There's a tricky spot. The percentage of Americans who trusted newspapers declined approximately linearly from 45% in 2000 to 22% in 2005. Find the average rate of change of the percent of Americans who have trust in newspapers per year. So the really important thing there is at the end it's telling you it matters which one of these things is y and which one's is x. On this last example, we're given a table where the input was the years and the output, the dependent variable, was deaths. So with this one, it feels like it's saying 45% in 2000, 22% in 2005. But we have to pay attention to what precisely they're asking us to find. And that is percentage per year. So otherwise, we're finding the percent over years. And this is our change in y, this is our change in x. So that means the year is our input variable, and the percent is our output variable. And the way that they wrote this makes it feel like the ordered pair is the other direction, but that's not what they're asking us to find. They're asking us to find percent per year. So year has to be input, percent has to be output, because again, this is change in y over change in x. So once you recognize that, and you can kind of spot that by, if you see the word per somewhere, that's going to tell you which thing is going to be your numerator, which thing is going to be your denominator, and then that will help you identify your x's and your y's. So for this, we want to write these ordered pair as 2000 is the year that goes with 45%, and 2005 goes with 22%. And so again, now that we have a nice kind of clear view of our ordered pairs, we'll do our slope, which is also average rate of change. In the notes, I haven't done it yet here, but I often I've been, I think, calling it M, but I should probably write average rate of change there. Same thing as slope in this case. So 22 minus 45, there's our y2 minus y1, over x2 minus x1, 2005 minus 2000, and so that comes out to negative 23 over 5, or as a decimal, negative 4.6. So what this means is, remember, we're in percent per year, so that means the decrease is, because it's negative, 4.6% per year is how the trust in newspapers was decreasing over that period. And then these last few examples are going to ask us to find the average rate of change based on an equation rather than these other prompts that we've seen. There's a couple of ways to write this from x equals negative 2 to x equals 3. If you notice back here, it's on the interval AB, so this is from x equals A to x equals B. You can say it either way, so just be aware that there's two widely used ways of indicating that. And that formula, let me copy it down right here. It's f of b minus f of a over b minus a. And again, that's just saying the second y value minus the first value, y value, y2 minus y1 over x2 minus x1, but just in interval notation. So what this is asking us to find is essentially f of 3 minus f of negative 2 over 3 minus negative 2. And this is, again, just our change in y. We just have to figure out what those values are. And then there's our change in x. So I think I'm going to evaluate f of 3 first and just make that a number, and then I'll evaluate f of negative 2, make that a number, and then I'll put it in here rather than trying to write it all out and evaluate within the average rate of change formula. So f of 3 is going to be 3 times 3 squared plus 4. So f of 3, that is 27 plus 4, and that is 31. And then we're going to do the same thing, f of negative 2, figure out what that is. So negative 2 plugged in there is going to be 3 negative 2 squared plus 4. So f of negative 2 quantity squared, that's positive 4 times 3 is 12, plus 4 should be 16. And so what this means is when x is 3, y is 31, and this means when x is negative 2, y is 16. So it's the same ordered pairs, we're just having to calculate what the y is. So coming back here, f of 3, that's our 31, our y value, minus 16, that's our f of negative 2 over 3 minus negative 2. I'll go ahead and call that 5 right now. And then that means our average rate of change, 31 minus 16 would be 15 over 5. So our average rate of change is 3. So just to recap, we have this form that is really just saying y2 minus y1, x2 minus x1, and for this we have to plug in our x's and our y's, our x's into our function to find our y values. So do the same thing with one more of those. So for this I'm supposed to find the average rate of change on the interval negative 1 and 5. So I'll just do f of negative 1 first. It doesn't matter which one you do first. So this is going to be negative 1 cubed plus 2 times negative 1 plus 2 times negative 1 minus 6. So f of negative 1 is negative 1, because negative 1 cubed would be 3 negative signs. Negative 1 squared would be 1 times 2, so that's 2, and then minus 2 right there, and minus 6. So f of negative 1 is, those just cancel, so it looks like negative 7. And then let's do f of 5. So that is going to be 5 cubed plus 2 times 5 squared plus 2 times 5 minus 6. So that's 125. 5 squared is 25 times 2 would be 50 plus 10 minus 6. And we get f of 5 equals 179. So that means when, from here, when x was negative 1, y was negative 7, and here, when x was 5, y was 179. So to find our, what would be, average rate of change equals, in this case it would be f of 5 minus f of negative 1 over 5 minus negative 1. So that would be f of 5 was our 179 minus f of 1, that was our minus negative 7 there. Again, always careful with those signs when there's a minus in the formula. And then 5 minus a negative 1 would be 6. And that comes out to 186 over 6, or an average rate of change of 31. So we're just going to evaluate and get our 2 points, and then we're essentially just doing the same thing, y2 minus y1, x2 minus x1.